In this video, we will learn about the basics of Amazon S3 and its benefits. Amazon Simple Storage Service is a service that is offered by AWS, which has a web service interface to store and retrieve data from anywhere in the world at any point of time. It uses an object storage architecture that can be used by customers of all sizes who want to store, retrieve, and protect any volume of data for a variety of use cases. These could range from creating data lakes to hosting websites and mobile applications. It is intentionally designed minimally for increasing the ease of usage and is highly stable and robust in its performance with a durability of 99.999%. The key benefits of Amazon S3 are: Amazon S3 is designed to be highly scalable and has low latency. It can cope up with changing demands of data storage to scale up or scale down without having to invest upfront in storage and security infrastructure. It is also highly durable, which ensures that the user's data is highly secure and protected against any failures, errors, network outages, or external threats. Users can store any amount of data on Amazon S3 and save costs by utilizing various storage classes that are classified based on data access levels and corresponding storage costs. S3 storage class analysis is a feature that enables users to identify data access patterns so that cost savings can be achieved. S3 intelligent tiering is another feature that automatically tiers objects based on changing access patterns and helps users save money by optimizing storage across different classes. S3 offers a highly secure service that helps users encrypt their data and limit or block public access through user access management tools. S3 also maintains a variety of compliance programs to help meet all regulatory requirements. S3 allows users to give or deny access to upload or download data. Users can replicate data across various locations worldwide or make changes across their datasets using efficient batch operations. Users can also analyze object usage and major trends in user activity. S3 allows users to run big data analysis on their data using query in place services. Using Amazon Athena, one can use standard SQL to query data stored on S3, and through Amazon Redshift, users can gain insights across all their data stored on S3. In this video, we will learn about categorization of data in Amazon S3 using buckets, partitions, and tags. S3 uses an object storage architecture where a unique key value is assigned to each object. Each object can be up to 5 TB in size and is stored in one or more storage buckets. Before uploading any object, such as a picture, document, video, or an audio, user need to create S3 bucket in one of the AWS regions. Buckets are akin to folders and hold any number of objects in them. All buckets have unique names across the AWS infrastructure. That is, once a bucket is created, no one else can create the same bucket across the whole world. Typically, a user should create buckets in their nearest AWS regions to minimize storage costs as well as to limit any latency in accessing the data. You can access buckets using the S3 console or programmatically using APIs. Buckets are non-transferable and typically users can access and create 100 buckets per account, which can be increased to 1000 buckets through a service request. Now, let us look at the storage architecture in more detail. Objects are fundamental storage entities on S3. Each object consists of object data as well as some metadata attached to the object. Amazon S3 has access to the metadata portion of an object, which describes the object. Typical metadata would include information about when was the object modified, type of content, or any other metadata that you can specify at the time the object is stored in a bucket. A key is a unique identifier for an object within the S3 bucket. Every object can be uniquely identified by a combination of a bucket, its key, and its version ID, which is unique to it. Amazon S3 also uses tags to categorize storage. Tags are key value pairs which can be added to any object at the time of creation or uploaded at a later stage. Each object can have 10 tags associated to it. Amazon History supports various API operations that are specific to object tags. For example, you can replace tags on an object programmatically or modify a set of tags. You can also delete a set of tags associated with an object. In this video, we will understand what is Amazon S3 Storage Lens and its features and workflows. S3 Storage Lens is a single view tool on Amazon S3 which enables users to gain insights on object storage usage and activity trends to make recommendations that can improve cost efficiency of data storage. Storage Lens is a cloud-based analytical solution that can scan multiple accounts in an organization and generate insights at a user level, bucket level, and even at a prefix level. Let us look at some of the S3 Storage Lens features. S3 has a console interface with interactive dashboards that have pre-configured views based on the intended use cases. For example, you can see an overall insight summary or view cost efficiency and data protection improvement recommendations. The Storage Lens dashboard can also be used to visualize usage trends and to identify any outliers. An example used for S3 Storage Lens would be to identify the buckets that are growing the fastest or to identify total storage across an organization. A user can download or export metrics in a CSV format to an S3 bucket for further investigation. S3 has an intelligent tiering system which enables users to optimize storage costs by automatically moving objects between access tiers based on access patterns. Once objects are uploaded to S3 intelligent tiering, it monitors access patterns and moves objects to tier structures based on frequency of usage as well as storage costs. Now let us look at Amazon S3 access tiers. The S3 intelligent tiering feature has 4 access tiers, out of which 2 are low latency tiers that are for frequent and infrequent access of objects. The other 2 are archive access tiers that can be activated individually or together to automatically archive objects that are rarely accessed. The first tier is frequent access tier, and the second tier is infrequent access tier. Objects uploaded to S3 intelligent tiering that are not accessed for 30 consecutive days are automatically moved to infrequent access tiers. Objects that are not accessed for 90 days consecutively are then moved to archive access tier and are further moved to deep archive access tier if they are not accessed for 180 days continuously. S3 intelligent tiering moves objects back to infrequent access tier as soon as they are accessed without any retrieval fees, thereby optimizing storage bills based on access patterns. Apart from S3 intelligent tiering storage, Amazon S3 also offers 4 different storage classes based on levels of availability, performance, and durability of data storage. The first is Amazon S3 Standard Data Storage class, that is for default storage of objects. The second is Amazon S3 Standard Infrequent Access Storage class, that is designed for data that is accessed less frequently. There is another storage class called Amazon S3 One Zone Infrequent Access Storage class that's offered at a discount of 20% compared to the 1A class and is used when data that is not accessed very frequently needs to be stored. However, the data is stored in one zone and is not backed up in 3 zones, which is the case for all other storage classes. Amazon also offers another long-term storage class called Amazon Glacier, which is designed to store data that is accessed very infrequently. The latency for data in Amazon Glacier is several minutes to hours. There's another layer called Glacier Deep Archive that is an alternative to Glacier having a retrieval time for over 12 hours, but is offered at just 25% of the cost of Amazon Glacier. In this video, we will understand what is Amazon S3 access points and its features and workflows. Typically, using the Amazon bucket policy, access to various buckets can be managed easily. However, as the number of users grow along with the datasets, it becomes complicated to manage access using a single bucket policy. Furthermore, it is complicated to provision access policies specific to users and applications without risking unexpected impacts for shared datasets. Amazon has created a feature called Access Points on the S3 platform. This simplifies access to different users for each bucket through an access point or a host name that users create, having its own unique policy. Permission to access a specific bucket can be configured to limit public access by object prefixes or tags. Access points can also be used to limit access to a VPC, that is, a virtual private cloud, to make sure that data stays within that specific VPC. An S3 access point can be created to support a single application or a user, or for a set of multiple users or applications at scale. In this video, we will understand what is Amazon S3 batch operations and its features and workflows. Amazon S3 batch operation is an Amazon data management feature that allows users to manage multiple objects across an organization at scale using a simple management console or basic API request. This is a lot more efficient to do at scale without having to develop custom coded applications to perform tasks across various buckets in an organization. To perform any operation, users need to create a job which consists a list of objects that need to be focused on, actions that need to be performed on those objects, and set of parameters specific for that particular operation. Amazon S3 batch operations allows users to run multiple jobs at the same time and also to set precedents of jobs based on priority. It allows users to track progress, send completion notifications, and also create reports for all changes that are executed by various jobs on the platform. To perform batch operations, first specific objects are identified, then within the management console, simple tasks to be performed are selected, such as copying objects within buckets, changing metadata or object tags, and retrieving objects from Amazon Glacier. Users can also use the Lambda function on Amazon S3 to perform slightly complicated tasks, such as processing data through a batch operation across millions of target objects seamlessly and quickly across an organization. In this video, we will understand what is Amazon S3 Block Public Access and its features and workflows. Block Public Access is an Amazon S3 feature that allows users to block public access across their AWS account or to specific buckets. Block Public Access supersedes other S3 access permissions and can be implemented by a few clicks within the console. Typically, public access is given through either access control lists or bucket policies or by both. And block public access allows users to block all public access to the specified buckets and objects across AWS account. It serves as an additional layer of protection for accounts and buckets, including the ones that will be created in the future, thereby ensuring that access is not granted to newly created items. In this video, we will have an overview of the S3 management console by modifying an existing S3 bucket and creating a new S3 bucket. We will look at some of the key features that are available for us. Now, let us proceed to launch the S3 Management Console. On a successful launch of the S3 Management Console, a list of existing buckets is displayed on the center of the screen. When we select one of the existing bucket, new options are available for us. We can empty a selected bucket or delete an entire bucket. In a big project or a group of projects where there could be many buckets, we could search the buckets by their names. Now, let us proceed to create a new bucket via the S3 Management Console. As we already know, AWS offers API endpoints to manage the S3 console. However, for the purpose of this video, we will only use Amazon S3 UI. For a successful creation of a bucket, we need to provide a unique name for our bucket. Do remember that no two buckets in the AWS universe can have the same name. After providing the name for our bucket, we need to choose an AWS region where the bucket will be hosted. The AWS region should be chosen so that it's closer to the clients. The clients could be human users or applications running on cloud or local servers. For the purpose of this video, we will choose an AWS region that is already selected by AWS for the AWS account that is currently logged in. Next, AWS also allows us to manage public access by way of public access settings. By default, AWS blocks all public access. However, block public access settings can be managed at the creation of bucket stage. We can allow full or partial access to objects in the bucket. To grant partial public access to buckets and objects, we need to manage access control lists, bucket policies, or access point policies, or all of these. It is recommended to customize individual settings to allow access to limited set of users or applications. Next, AWS allows us to enable or disable bucket versioning. Bucket versioning becomes an important feature to recover objects from an unintended action, such as an application failure. Enabling bucket versioning will make sure that each change that is applied on an object is stored as a new variant in the database. The tags are used to label buckets. You could use same tags for buckets in individual projects and group of projects to allocate costs effectively. AWS uses these tags to organize your resource cost on your resource allocation report. Moving forward, we can disable and enable data object encryption. Let's keep this as default and proceed to click on Create Bucket button at the bottom of the screen. Now a new bucket is created. Now, as we can see, we have 3 different buckets with different access, with same AWS region, and with unique names. We can also see the creation date in the last column. Now, if we go inside an existing bucket, we will see its properties and the data included in the bucket. Let us look at one of the bucket from before. As you can see, there are different items included in the bucket. Those can be selected and performed actions over. And we can access bucket properties, bucket permissions, other metrics, and manage the buckets. We can also manage access points for this bucket. With this, I will end this demonstration and expect you to launch your own S3 management console, create your own buckets, and manage your own settings as per the requirements of your projects. In this video, we will see how Amazon S3 can be used, and we will understand its role as the foundation for any data-related functionality for AWS. Using AWS S3, we are able to create scalable and durable backup solutions, and we can also replace and add to on-site storage capabilities. Also, we are able to protect sensitive data and applications without investing in additional infrastructure on-site. This can be done quickly on the Amazon S3 platform and help protect against systemic and natural failures. We can quickly create data lakes on the Amazon S3 platform and use various query in place analytics as well as machine learning tools to gain insights. We can use S3 storage classes for long-term data storage with low usage rates to reduce storage costs and to replace physical infrastructure for data archiving on-site. In this video, let us learn some examples of how global businesses are using Amazon S3 to tackle real-world problems. First, let's take an example of Netflix. Netflix uses S3 for most of its computing and storage needs. The streaming content of Netflix is hosted on S3 and is available to millions of users around the world at the touch of a button without any latency. By deploying thousands of servers and using them for storing terabytes of data, Netflix is able to leverage a robust, secure, and highly durable Amazon S3 architecture. Next, let us look at an example of GE Healthcare. Medical data coming from millions of medical devices, primarily consisting of medical imagery, is stored on Amazon S3 by GE Healthcare. It gives them durable, secure, and reliable storage for critical data. Whereas Ryanair uses Amazon S3 Glacier and the S3 Glacier Deep Archive for long-term storage of the data, having switched to a cloud-based storage from tape backups, thereby saving 65% on their backup costs annually. In Amazon Simple Storage Service, we have learned about Amazon S3, including its organization and architecture. Thereon, we learned about Amazon S3 features, including storage lengths, intelligent tiering, and batch operations. Thereon, we learned about Amazon S3 access points and block public access. Finally, we learned about Amazon S3 use cases and case studies. And in the next course, we will learn about data movement.